the arrow over there. Okay, so this is element H. Okay, so now we're going to construct element K now. Okay, so we're going to construct element K with the associated stresses. Okay. So we have this. I'm going to still use the same transformation. Okay, I will use the left side. Okay, so now element K from this view is on the other side, right? So the curvature will look like this. Okay. And we know that it has a normal stress coming in the Z direction. So this is equal to 89.127 times 10 to the power 6. So now the shear stress, right, is coming, the dominant one is due to the 17.687 that is induced by the torque, right? Whereas the shear the shear stress induced by the shear force is only 2.358. So now, right, the shear stress is coming down this way. Okay, and this is equal to 15.331, right, times 10 to the power 6 Pascal. Okay, so now the as I said, the most important thing now is the construction of the shear stress. Okay, this is the most critical component now. Okay, so I don't want you to be confused in terms of when is add, when is minus, or at the end your final result is positive or negative. At the end of the day, the most important thing is the orientation over here. Okay, that's the most critical part. Anyone, any question? Let me look at my chat. I don't see anyone having any issue on the chat. Okay, so this is the, if today's lecture, what is the most critical component that you learn? This is the one. Okay. Okay, so in your term test, I'm going to test you until construction of the elements. Okay, I understand the homework that I posted last week asked you to find principal stresses. Okay, I will not ask you in your term test 2 to look for principal stresses or maximum shear stress. Just construct the element. Okay, that's enough. Okay. Okay. So what I'm going to do next is I'm going to now start the lecture on 2D and 3D Mohr Circle. Okay, and then you will appreciate from this element how to construct principal stresses, how to draw the Mohr Circle, things like that, which I did show you briefly in week 8 Tuesday, which is this long example. Remember, we went through this long example, right, where we construct the element, and then we also did construct the Mohr Circle, right? Like this is week 8 Thursday. I think we did construct Mohr Circle already. Okay, now I'm going to go into detail on constructing the Mohr Circle. Okay, I believe some of you have not taken 3C yet. Okay, or you have taken 3C, you forgot everything. Fine, I'm going to teach you Mohr Circle as everyone has no prior knowledge on Mohr Circle. Okay, right. Anyone not clear with the orientation? I think you guys are all okay. If not, you can speak up on your mic, or you can type. Okay.
Hey,
Yes.
so how did it determine the orientation exactly? Could you like explain the arrows?
Yes. So, okay, let's look at element H, okay? So on element H, the arrow going upwards due to the shear stress is 17.689, right? And then on and due to the shear force is 2.358. And if you look at those arrow, and I'm going to put it into this diagram over here, is in this orientation. Yes. Okay.
Yeah.
So yeah. So that's why it's in this orientation over here. Now element H is easy. The confusing part is element K, right? So element K over here, the shear stress induced by the torque, right? So this one I'm circle a bigger circle now, is 17.689. Now 17.689 is greater than 2.358, right? So when that's the case, so 2.358 is going in the opposite direction, okay, compared to 17.689. So 17.689 is, I'm going to use a different color, is coming in this direction now, okay? So that's where we have this orientation over here. Because the higher magnitude dominates the orientation of the shear stress. Does that make sense to you? Is that okay or no?
Yeah, it makes sense. Thanks.
Okay, okay. As long as it makes sense to you, I'm okay. Okay. So next we are going to into Mohr Circle. Now Mohr Circle is very important topic. It's a topic that you will use now in your other courses 305, or also if you take your technical elective in finite element, you are also going to see Mohr Circle. Okay, so I'm going to start with Mohr Circle.
Sorry, someone in the chat asked something else.
Okay, thank you for letting me know. I'm not getting. May, what? Can you?
Like if we have an element on the top of the circle, and how did you determine the Q direction?
Good question. Okay, so May asks. Now you have over here, right, an element. So element H I. So I call it element J. Okay. So this is a classical question that you'll be figuring out also. So what is interesting now, if we were to construct the shear stress distribution, so this is our shear stress due to the shear force, okay, and this is due to our Z. You have a shear stress distribution like this. So over here, this value over here, the shear is equal to what? May, does that make sense? Is equal to 0, right?
All right, yeah.
Right. So yeah, because now we are looking at detailed distribution now, right? So the dominating one now is the shear stress due to the torque is constant at the radius, because the formula is equal to what? This formula is equal to what? Torque is equal to T R over J, and element H, K, and J are on the outer radius. They all are constant. Okay, that's really a good question. So the orientation is more straightforward. I picked H and K because they are the most confusing one. I did not do the top and bottom, but you asked a really good question on it.
All right, thank you.
Okay. So we are going to now go into Mohr Circle. As I say, it's one of the most important topics in solid mechanics. Okay. Okay, and I will highlight will not test. On the test 2. Okay. So let's look at Mohr Circle. So before we go on Mohr Circle, we are going to look at stresses now. Okay. So the first thing I'm going to teach is plane stress. Definition. Okay. So you read textbook and they say the structure is under plane stress. What does it actually mean? Okay. So I'm going to construct a 3D element now. Okay. So this is our X, Y, this is our Z, and I'm going to draw our element. And the element I'm constructing is a 3D element. It's not a cube. Okay, it will always look like this. Okay, when I say look like this, what does it mean? It will have one face that is bigger than the other. Okay, so let me elaborate. So you will see this, right? So the biggest face, so XY plane has the largest surface. So one of the plane will always have the largest surface when we construct the element, like you see over here, right? Like when I draw the element over here, one of the face, like over here, this is my so-called YZ plane, right? Is the largest surface, okay? So when you construct the element, always you have to have one of the plane have a biggest area compared to the other two, and I'll tell you why later. So we know that this is over here, we have our stresses, or we define that this is stress in the X direction, stress in the Y direction, and coming up this way is stress in the Z direction. Okay, so as the name imply, okay, plane stress condition okay, so plane stress condition is when stress X and stress Y are not equal to 0, where stress Z is equal to 0. Or when stress X and stress Z is not equal to 0, stress Y is equal to 0. Or when stress Y and stress Z is not equal to 0, stress X is equal to 0. So what you can see over here is as long as one of the stress orientation is equal to 0, we call this a plane stress condition. Okay, so this is the first thing you. So later on, when you learn in finite element, okay, or in 305, they say calculate the or analyze the structure in plane stress condition, you have to know which orientation we will have when the stress field or the stress magnitude is equal to 0. Okay, that's the first thing you have to know. So if we go back to our problem we had before, right? You will see this. Okay, so you'll see that our for this case stress X is equal to 0. Okay, now stress